This video will be completing problems 1 through 20 from your Algebra 2 final exam review packet. Alright, so let's get started. Alright, problem number 1 asked us to sketch the graph of, I think I want to turn this over, I don't need all that. Alright, sketch the graph of f of x is equal to x minus 1 if x is less than 0, and f of x is equal to 4 if x is greater than 0. Alright, so we have a piecewise function here, and the way we've done piecewise functions in our class is that we first want to recognize how many pieces we have. In this case we have 2 pieces. Alright, we have a piece that gives us y is equal to x minus 1, and we have a piece that gives us y is equal to 4. Alright, we make 2 table of values. Alright, and in those table of values we want to find our critical point. In this case our critical point is 0. Alright, and that's the point we want to put in both tables. The first piece has an open circle with it. It's going to have an open circle. And the second piece is going to have a closed circle. Alright, for the first piece we want to find values of x that are less than 0. So we can go -1, -2, why not, -3. And we want to plug these values into our equation. So 0 minus 1 is -1. -1 minus 1 is -2. Plugging -2 in gives us -3. Plugging -3 into the equation gives us -4. Alright, so we got plenty of values. Alright, in this case, we want to find values that are greater than 0. So 1, 2, 3. Those would be values greater than 0. Alright, and it really doesn't matter because, well, regardless of your x value, your y value is always going to be equal to 4. Alright, so let's graph that. Alright, we have an open circle at, see if we can do a little bit better job than that. Alright, move this over some. There we go. Alright, we have an open circle at 0, -1. Alright, and then the rest of the points we want to plot. So 1, -2, -2, -3. Alright, and we see that those points go in that direction. Alright, here we have a closed circle at 0, 4. 1, 2, 3, 4. Alright, closed circle. Alright, and we can go 1, 4, 2, 4, 3, 4, and so forth. Alright, and we make the ray. Alright, and there's number 1 done for us. Alright, keep it moving. Alright, number 2 and number 3. Alright, so number 2 and number 3, they say write a function that write the functions that represent the graphs below. Alright, so for number 2, alright, we're going to scroll down a little bit more. Alright, number 2, alright, if we look at number 2, we have 2 pieces here. Alright, so we want to start with and f of x is equal to, make that little bracket. Alright, and we usually do this backwards. Alright, so we find out where the 2 graphs switch. Alright, that critical value. In this case our critical value is 0. Alright, 1 piece is to the left, so x is less than 0. 1 piece is to the right, where x is greater than 0. Alright, now one of them has the closed circle, and the one with the closed circle is the piece to the right. So it gets the equal sign. Alright, alright, and then from here we're pretty much doing slope and y-intercepts. Alright, so the piece to the left has a y-intercept at 1, 2, 3. The piece to the right has a y-intercept at 1. Alright, from here we can figure out our slopes, and we want to put our slopes in the front. I keep erasing this and moving it over. Alright, and so my slope for this is up 1, left 1. So that would be 1 over -1, which is -1. Alright, up 1 and to the left 1. Alright, or up 2 and to the left 2. Alright. And then the slope for the piece to the right is up 1 and to the right 1. So that would be 1 over 1, which is 1. Alright, and there is your function. Now, you don't need the 1's. You can erase the 1's and just have negative x plus 3 and x plus 1. Alright. The second problem, number 3. Alright, now the critical value is not at 0 like before, but it is at 1. Alright, it's at x equals 1. Alright, now the piece to the left has a open circle, and the piece to the right of 1 has a piece to the right or greater than 1 has the closed circle. Alright, so there's the first part of pretty much the domain part. Alright, and from here we want to look at the rest of the graph to figure out, well, we got to still figure out y-intercepts. Alright, so well, let's look at the piece to the left first. That's easier. Alright, the piece to the left has a y-intercept at -1. So we got -1 here. Alright, now the piece to the right doesn't show a y-intercept, but if we extend this, we can see where the y-intercept would be. Alright, and so let's see. This looks like a clear value. 1, 2, 3. Okay, we're pretty clear here. Alright, that we're going to go up 3 and to the left 1. Left 1. So if we go up 3, 1, 2, we're off the graph, but that's okay. Up 3 and to the left 1. Alright, to the left 1, it will put us at, let's see, 1, 2, 3, 4, 5, 6. So it gives us a y-intercept of 6. Alright, now, since we are dealing with the right piece already and we see the slope is a rise 3, put the x here. Alright, a rise 3, up 3, and to the left 1. Alright, that becomes our slope. Alright, which is just equal to -3. Alright, the slope for the piece to the left is up. Since we see that y-intercept, it's up 2 and to the right 1. Alright, so that slope is 2 over 1, which is just equal to 2. Alright, keep it going. Number 4 says when ordering gift wrap, when ordering gift wrap, When ordering items from a catalog, the buyer has an option of having items gift wrapped. The shipping cost for every order is $12. In addition, if 5 items or less are gift wrapped, the charge is $5 per item gift wrapped. If more than 5 items but less than 10 items are gift wrapped, the charge is $4.50 per item gift wrapped. If 10 or more items are gift wrapped, the charge is $3.50 for each item gift wrapped. So, if you look at the situation, it says write a piecewise function for the total charge of the gift wrap of X items, including shipping charge. All right. So total charge, we're going to say C for total charge, and what we have is 3 situations. All right. Now, regardless of the situation, you're always going to pay how much for shipping? You got it, $12. All right. Now, you got 3 situations here. All right, and you just need to be clear with your 3 situations. All right. If 5 items or less is one situation. All right, you're paying $5 per item gift wrap. If it's more than 5 items but less than 10 items, that sounds like a between. All right, we're going to pay $4.50. All right, and if 10 or more, we're going to pay $3.50. All right, so kind of highlight the information that we need in the problem. So let's go ahead and see if we can get this done. All right, so let's look at our different situations, or what causes our different cost prices. All right, one was 5 items or less. All right, now that means that we could say X is less than or equal to 5. And since it's a real world situation, we know we're going to have 1 to 5. All right, so that's okay. We're not going to have negative items gift wrapped. All right. In that case, you're going to pay $5 per item. All right. So if it was 1 item, we would pay $5 plus 12. If it was 2 items, we'd pay $10 plus 12, and so forth. All right, till we get to 5. All right, now the second situation says it has to be more than 5, but less than 10. All right, now that means it's not including either one of those. So we say 5. When we say something between, we say it's less than X, which is less than 10. It's not including either one of them. All right, and in that case, we pay $4.50 per item. All right, and then if 10 or more items are gift wrapped, so we say X is greater than or equal to 10, we're going to pay $3.50. X. All right, and so there's your piecewise function. All right, it says what is the total charge including shipping if 14 items were gift wrapped? All right, so 14 falls into this third option. All right, and so we're going to go $3.50 times 14 items plus 12. All right, in that case, $3.50 times 14 plus 12 is equal to $61. All right, number 5, if you remember in class, the absolute value functions were the ones where I was doing a little cheerleading thing. All right, and we need to remember the standard form for a absolute value function is a times the absolute value of x minus h plus k. All right, where the vertex would be h comma k. All right, and we use A as our movement. We go up and out or down and out. All right, and so if we recall that, we should be able to do this problem pretty quickly. All right, it says let g of x equal 3 times the absolute value of x plus 2, excuse me, minus 4. All right, if that's the case, our vertex is going to be -2, -4. All right, our out movement and our absolute value function is going to be 3 over 1. All right, which means that we're going to go up 3 units every time we go out 1 unit. All right, so you can kind of imagine, remember us doing this. All right, so let's graph that. All right, 1, 2, 1, 2, 3, 4. All right, is our vertex. All right, and so we're going to go up 1, 2, 3, and out 1. All right, out because we go left and right. All right, again, you can go up 1, 2, 3, and out 1. All right, and the same thing in the other direction, 1, 2, 3, and out 1. All right, and our graph will look like that. All right, so it says, what is the domain of g of x? Now, the domain for all absolute value functions is going to be all real numbers. A couple of different ways you can write all real numbers. You can just say all reals. All right, write all real numbers out, or you can say from -infinity to infinity. All right, what is the range? Well, it does not go to -infinity. It starts at, in the y direction, it starts at -4, all right, and goes up. So we say y is greater than or equal to -4, all right, for d, all right, which we have already said. All right, the vertex is -2, -4 for E. All right, it's asking us to write an equation of the axis of symmetry. Now, your axis of symmetry is that vertical line that splits it in half, goes through the vertex, and that is x is equal to -2. All right, F. What is the minimum value? Well, obviously, the furthest down is -4, so we say a min. Our min is -4. All right. G. All right. Describe. All right. We're describing the transformation. All right, and so our transformation for this graph, we use our AH and K values. So we can say with a equaling 3, we can say it is wider, or I think they say vertically stretched is what they probably say. And we talked about stretched by a factor of 3. All right, that's what A does for you. H equaling a -2 would let you know that there is a shift to the left 2. K equaling -4 lets you know that there is a shift down 4. And I guess we should say units for both of those. All right. And then it says, is the function continuous? Well, I can draw it without picking my pencil up. The arrows have nothing to do with continuity in this case. So for H, we say it is continuous. All right, number 6 and 7. All right, it is composition functions. All right, and so they're asking us to find f of g of 3. All right, simplest way to do this is to take 3 and plug it into g, get an answer. So if we do that, g of 3, all right, g of 3 is equal to 2 times 3 minus 8, all right, which is 6 minus 8, which is negative 2. All right, so now we say g of 3 is equal to negative 2. So now I take negative 2 and plug that into the f function, and that's going to give me negative 2 minus 3, which is equal to negative 5. All right, so that's number 6. All right, number 7. All right, h of f of negative 7. So what are we doing? We're taking the value negative 7, plugging it in the f function, evaluating, simplifying that, and then plugging it into the h function. So if we do that, f of negative 7 is going to give us negative 7 minus 3, all right, which is equal to negative 10. All right, and then we're going to go h of negative 10. Well, h of negative 10 is negative 10 all square minus 2. That's 100 minus 2, which is 98. All right, number 8 through 13, we're using the 3 functions that are there. All right, first we're adding f of x and g of x. So for number 8, we should have x minus 3 plus 2x minus 8. We are combining like terms. That's going to give us 3x minus 11. All right, number 9, we are subtracting f of x and g of x. And when we use subtraction, we want to put the second piece, all right, in this case, g of x in parentheses, 2x minus 8, to make sure that we subtract. We go minus a negative 8, so we're going to go x minus 3 again, minus 2x, all right, and we want to make sure we subtract this negative 8, and if we do that, this becomes a plus 8, all right, and so our answer is going to be x minus 2x, which is a negative x, and negative 3 plus 8, which is 5. All right. All right, number 10. All right, it's asking us to multiply the two. All right, and in order to do that correctly, all right, we got x minus 3 times 2x minus 8. So it looks like we're going to do some foiling. First, outer, inner, last. Some people say distributive, all right, because you're distributing the x, all right, and you're also distributing the negative 3, all right, into the second binomial. All right, regardless of which way you do it or say it, it's still foiling. All right, so we're going to go x times 2x is 2x squared. X times negative 8 is negative 8x. Negative 3 times 2x is negative 6x, and negative 3 times negative 8 is 24. We combine our like terms, which happens to be the outer and inner, or the middle terms. All right, and that's going to give you 2x squared minus 14x plus 24. All right, number 11. All right, we have f of x over g of x. All right, and to just, to do that, just a matter of putting one on over top of the other, x minus 3 over 2x minus 8. All right, and they usually ask you for a restriction. All right, and if they do, which I've seen on the final before, where it says, well, what is the restriction? All right, and the restriction is setting the denominator. Now, we usually say equal to 0, right? But this time we say not equal to 0 to find out what value won't be viable. All right, and to do that, we finish solving. Plus 8. All right, 2x is not going to be equal to 8. Divide both sides by 2. And x cannot be equal to 4. All right, so that's part of this division. Before, all we did was that. All right, number 12, they're asking us to do the composition. So we're doing g of h of x. All right, and we kind of lost our functions up here. So let's keep our functions. I know you have them on your paper. All right. All right, and so in this case, I'm putting h of x into g of x. All right. So the h of x function. All right, the h of x function, all right, which is x squared minus 2, goes in the g of x function. All right, the g of x function is 2x minus 8. Wherever I have an x, I'm going to put this whole thing in there. So g of h of x is 2 times x squared minus 8. Oops, I'm sorry. Yeah. No, x squared minus 2 minus 8. All right, and usually we ask for to simplify this a little bit, do distributive property. This gives you 2x squared minus 4 minus 8, and that's equal to 2x squared minus 12. All right, number 13. All right, we have h of f of x. All right, in this case, we're going to put the f of x function into the h of x function. All right, looks like we're going to have a little bit of work to do for this one. All right, the f of x function is x minus 3. So this is going to be x minus 3 all square minus 2. All right, and sometimes we can leave it like that. It's that is in a sort of vertex form. All right, but sometimes they ask us to put it in standard form. All right, and if they do, then we got to go x minus 3 times x minus 3, because it's squared, minus 2, meaning we're going to FOIL this, or distributive. That's going to give us x squared minus 3x minus 3x plus 9, x squared, negative 3x plus 9, minus 2, can't lose the minus 2. And then we want to combine like terms, all right? So combining like terms would give us a final answer of x squared minus 6x plus 7. All right, one more. Oh, no, that's it, 13. 14 through 17, they're asking us to state whether or not the function is one-to-one. All right, in order to figure out whether something's one-to-one, it has to pass the, well, if it's a function, it already passes the vertical line test. All right, but it also has to pass the horizontal line test. All right, so let's graph these, all right, and see if they're one-to-one. All right, f of x, and you can look right in your calculator if you would like. All right, f of x is equal to 2x minus 5 is a line. It's linear. It goes through y-intercept at -5, and it goes up 2 over 1. All right, and so a quick sketch, and you can look in your calculator, all right, will give you a graph like that. All right, it obviously is a function, so it passes the vertical, all right, and it also passes the horizontal. So you might remember these. All right, so it is 1 to 1. Let's keep it moving. All right, f of x is equal to negative x squared, which we graphed earlier, yesterday, with the increasing decreasing interval. All right, in our graph, if you graph it, but you should know by now that it's a parabola that goes through the origin and it opens down. Now, this is obviously a function, we're good there. All right, but if you see, it does not pass the horizontal line test, and so it is not 1 to 1. All right, and none of the parabolas are going to be 1 to 1. All right, an absolute value function, all right, shaped like a V, all right, absolute value of x, all right, diagonal, all right, at 0, 0, it goes up 1, out 1, up 1, out 1, all right, is not 1 to 1. All right, and f of x is equal to x cubed minus 9x. Now, any of the x cubes, I've suggested that you go to your calculator and check to see what your calculator is saying for those. All right, so we're going to go x math 3 minus 9x. All right, look at the graph. Ooh, all right. And so the x cubes can be different every time, all right? Some of them are 1 to 1, some of them are not. So it's a good idea to check the graph. All right, this graph looks a little like that. All right. All right, and that's obviously not 1 to 1. All right. All right, number 18. All right, f of x is equal to 7x minus 6, and g of x is equal to x plus 7, x plus 6 all over 7 divided by 7 inverse functions. Verify your answer algebraically. All right, so there's really one way of doing this. All right, and we say that if f of g of x and g of f of x are equal to x, all right, then they are inverses of each other. All right, and so we need to go f of g of x, all right, for this. All right, and if we do that, we're plugging g of x into f of x. All right, and so that's going to be 7 times x plus 6 over 7, all right, minus 6, all right. And what we see is that if they are inverses, things will start canceling really easily. All right, in this case, the 7's cancel. All right, that leaves us with x plus 6 minus 6. The 6's cancel, all right, and we are left with x, all right. We do the same thing with g of f of x, all right, just to be clear, all right. If I plug f of x into this function, I'm going to get 7x minus 6 plus 6 all over 7, all right. And so the first thing that cancels are my 6's in this case. All right, that leaves us with 7x over 7, all right, which is equal to x because my 7's cancel, all right? And so they are inverses, and that's how you verify your answer algebraically, and that's what you'll be asked to do. All right, number 19. Very similar problem, but in this case, they're asking you which one represents the inverse function. All right, now, if we're given a function and ever asked to find the inverse function, we do first thing we do is switch x and y, And then 2, we solve for new y. Alright, and then we call it y to the negative 1. Alright, in this case it's f of x, and so it's a very similar situation. Alright, so we go f of x is equal to 1/3 x plus 5. We change the f of x to a y, since they're the same. Alright, for what we're doing. Alright, and then so I do step 1, which is to switch my x's and y's. X is equal to 1/3 y plus 5. And then I solve for the new y. Alright, solving would, I would subtract 5 from both sides. Alright, that's going to give me x minus 5 is equal to 1/3 y. Alright, and I want to get 1/3, I want to cancel the 1/3, so I multiply both sides by 3. Alright. Alright, the 3 and the 1/3 cancel, and that'll leave us with y. Alright, and we want to call it inverse. Alright, and here I'm going to do distributive property. Alright, and so that's going to be 3x minus 15. Alright, that's the inverse, and that one is what? D. Alright, and then the last problem of the day, alright, number 20, real simple problem. Alright, it says the set of points 2, 7, 5, 8, negative 3, 6, 9, 1 represent a function. Write the set of points that represent the inverse function. So we follow the same rules we did before for step 1. To find the inverse, we want to switch our x's and y's. Alright, so the inverse set of this set, make my bracket right, alright, would be, instead of 2, 7, it would be 7, 2. Alright, instead of 5, 8, it would be 8, 5. Alright, instead of negative 3, 6, it would be 6, negative 3. Alright, and instead of 9, 1, it would be 1, 9. Alright, and that's that.